All right, guys, third and final video for the week. And so I just wanted to work through some notes. The zombie activity was just kind of a fun-ish way to demonstrate what exponential growth would look like, or exponential decay as well. But what I want to do now is I want to look at, if you're given a word problem, I want you to be able to write a growth or decay equation or function given a certain situation. Okay, so exponential growth is a situation where we start low and the numbers increase. Okay, so growth means there's an increase. Okay, it means it is getting bigger, moving up. Okay, and so the general equation looks similar to the function that we looked at in the zombie notes, but we've got a little bit of extra here. So we have y equals a parentheses 1 plus r all to the t power. Okay, so this is similar to the y equals a times b to the x, okay, with a few differences. So the y is our final value. It's our end result. The a is our initial value. Okay, initial means that is the start, the beginning. Okay, final means what we have at the end. Okay. R is going to be the rate of growth. And we're always going to write our rate as a decimal. Okay, and then T is the time that has passed. Let's see if I can focus a little bit here. Okay, so lots of pieces, but after you see a few of these, they're not quite as complicated as they look. Usually what we're looking at is our initial value and our rate of growth. Okay, those are usually, not always, but usually the two pieces of information we're going to be given, and then we're going to want to plug it into an equation that we could use then to predict future values. So I'm going to do example 1 and 2 with you, and then I'm going to leave the practice blank for you to try on your own, but I am going to post the answer key with the practice problems completed as well. Okay. Example 1, population. The population of Johnson City in 2005 was 25,000 people. Since then, the population has grown at an average rate of 3.2% each year. Write an equation to represent the population of Johnson City since 2005. Okay, so they told us that in 2005 the population was 25,000, and we know that it has grown at a rate of 3.2%. Now, one thing we're going to have to remember is when they give us a percentage, we're going to have to change that to a decimal. The way we do that is we find our decimal point and we move it 2 places to the left. Okay, and then in any empty spaces we have, we put a 0. So this 3.2% is going to be written as 0.032. That's the way we're going to write our rate. Okay, so we know that our initial value is 25,000. And we know that our rate is 0.032. Okay. So if I start with my function, y equals a times 1 plus r to the t, I'm going to plug in the values they gave us in the problem. Okay, so I know what my 25,000 is, and I know what my a is and what my r is. So I'm going to rewrite this as y equals 25,000, that's my a, times 1 plus 0.032 to the t. Okay. And then the only thing I'm going to do is I'm going to take this one step further, and I'm just going to clean up what I have in the parentheses. And my final answer is going to be y equals 25,000 times 1.032 to the t. And that is the function that could be used to predict future populations. Oh, I forgot a 0. Just kidding. There we go. 25,000 times 1.032 to the t. And for today, all I want, or for this week, all I want you to be able to do is just that. I want you to be able to write the exponential function that goes along with the problem. Another time we may get into actually using it to predict numbers, but today I just want you practicing writing the functions. Okay? So let's do one more example. Example 2, investment. The Garcias have $12,000 in a savings account. The bank pays 3.5% interest on savings accounts, compounded monthly. Write an equation to represent the account balance T months after the initial investment. Okay, so we have two values. We know that they start out with $12,000 in the account, and we know the rate of interest that the bank pays them is 3.5%. So again, 3.5%, I'm going to have to write that as a decimal. So I'm going to move my decimal point 2 places to the left and write it as 0.035. So for this problem, A equals 12,000 and R equals 0.035. I'm going to plug that into my basic function, my general equation. Y equals A times 1 plus R, all of that to the t. So Y equals 12,000 times 1 plus 0.035 to the t. And then just to clean that up one more time, I'm going to put those together. Y equals 12,000 times 1.035 to the t. And that is our exponential growth function. Okay, I can tell this is a growth function just by looking at it because this number is bigger than 1. Okay, so 1.03. Because this number is bigger than 1, this is going to be a growth function. The numbers are going to grow or get bigger. Now, on the next page, we're going to look at what a decay function. Decay just means they're getting smaller and how those functions are different and what those look like. So again, stop here and practice. Do the 2 practice problems on your own, and then I will post the answer key on Classroom where you can double check your work on the practice problems. Okay, exponential decay is very, very similar. Okay, but decay means there is a decrease. The numbers are getting smaller. They are going down. Okay. That is what exponential decay would look like. So this would be like when we were fighting the zombies, killing the zombies on the zombie videos. Okay, those would be examples of exponential decay. The basic equation is exactly the same, except now instead of adding the rate, we're subtracting the rate. Okay. Y is still our final value. A is still our initial value. R is our rate, but it's our rate of decay. Okay, at what rate is it decreasing? And T is our time. So I'm going to do one example here, and then again, the practice problems are there for you to do on your own, and you can double check them on the key that I post on Classroom. So example, depreciation. Depreciation, that means something's getting smaller. The original price of a tractor was $45,000. The value of the tractor decreases at a steady rate of 12% per year. Write an equation to represent the value of the tractor since it was purchased. So we have 2 numbers. We have the initial value of the tractor when the farmer bought it, and then we have the rate at which it is decreasing. Okay, so 12%. Notice I don't see a decimal point there. That means it's here, 12%. That's a whole number 12. But to write that as a decimal, we have to move that decimal point 2 places to the left, which means this is the same as 0.12. So if we use our function, y equals a times 1 minus r to the t, we know that a, our initial value, is the 45,000. And we know that r is 0.12. So we're going to plug those into our general equation, and we get y equals 45,000 times 1 minus 0.12 to the t. And now when we simplify, this is where it's different than a growth function. 1 minus 0.12. And I know you guys will use a calculator if you're, or just do it in your head. Gives us 0.88. Okay. So we have y equals 45,000 times 0.88 to the t. And that is our growth function, or excuse me, that's our decay function. And I can tell it's decay because this number is smaller than 1. Okay, and that's where it's different from our growth functions. So again, there are 2 practice problems on here for you. Again, this is not for a grade, but I guarantee you if you work through these, it's going to help you a lot on the quizzes that I'll assign later today that is for a grade. So make sure that you're going through the videos, trying some practice problems, and please, please, please don't forget to check in with me. Check in with me whether you need help or not, but especially if you have any questions, I will be happy to work through this with you or help you out in whatever way I can. Talk to you soon. Bye-bye.